Good morning, everyone, and thanks for joining us for today's webinar on energy efficiency for small and mid-sized businesses. All of our PG seminars and webinars are in part sponsored by the Energy Trust of Oregon. We work together to make sure the concepts and recommendations you learn in our events are consistent across all of our individual programs and services. Well, I wanted to tell you that we are broadcasting from lovely Portland, Oregon today, where it is June and it is scheduled to rain. And I don't want to put anybody off by that because we do make the most out of it, out of our rainy weather. So today I wanted to talk to you about, we are going to discuss some simple ideas for saving energy at your place of business. Some of these are small tips and tricks you can do yourself. Other ideas discuss efficient investments you can make to help curb your energy use and potentially lower your bills. First, we'll learn how to calculate how much power you actually use in your business day to day and what that costs. Next, we'll discuss how different businesses use energy and their potential for energy savings. Then we'll talk specifically about improvements that can be made to building systems, in particular lighting and HVAC. And finally, we'll cover some low-cost and no-cost tips and available programs that help businesses engage in efficiency measures. Okay, let's talk about some quick definitions here. First thing I want to talk about is power. Power is the rate at which work is done. We measure electrical power in watts. Many people think in terms of batteries, which are measured in volts. For example, I can buy a 9-volt battery, which is more powerful than a 1.5-volt AA battery. But volt measures current, not power. Power is measured in watts. Compare it to a car. Watts is like the horsepower. Watts is the punch. Watts is the basic unit of electrical power measurement. Now, when we talk about energy, energy is power over time. So it's watts of power in a given time, say hours. If you put them together, you get a watt hour. On your bill, it's measured in kilowatt hours. So let's see how this is applicable. When we measure electrical use, we take the amount of power in watts times the time it's used in hours, and we get a watt hour. Watts are small, so to measure the energy in usable units, we use units of 1,000 watts or kilowatts. So 1,000 watts is in an hour is a kilowatt hour, and it's noted as kWh. For example, if I told you my car was worth 1,000,000 pennies, you would kind of look at me strangely. But if I told you it was worth $10,000, you would understand the concept. Same amount, different units. So with electricity, we use kilowatt hours or kWh. So let's do this calculation. We're going to do the calculation of this 100-watt incandescent bulb. Anytime you turn this bulb on, it uses 100 watts. So let's say we were going to have it on for 8 hours a day, every day of the year. That's 8 times 365, or 2,920 hours. So you get, with that, you get 292,000, 100,000 hours, 100,000 watts minus the hours divided by 1,000, and that equals 292 kilowatt hours. And here's a graphic just to kind of review what I just discussed. We have our 100-watt light bulb, and you multiply it by the hours used in a year. That's 8 hours a day. And then you get the formula to calculate how much energy this uses. So to get the watts from the kW, you divide it by 1,000. So why is this important? Well, it's important because you get charged for every kWh or kilowatt hour you use. So here's some more numbers for you. What we talked about before, the basic billing unit for PGE for energy is kWh or kilowatt hours. And the amount that you're charged just depends on the type of customer that you are. Small commercial customers are Schedule 32, and they use less energy than the next tier up, less peak energy than the next tier up. So that's how we define our small business customers to our medium-sized business customers, is how often they exceed a peak amount during the year. So you might be a Schedule 32 customer, or you might be a larger customer, which is a Schedule 83. Basically, if you're a small business customer, you're charged 8 cents per kilowatt hour, and if you're a larger customer, it's 7 cents per kilowatt hour. So in our example, we have the cost for a small commercial customer, and the example is to run that bulb for a year. So we do the calculation with the hours used per year divided by 1,000. We end up with 292 kilowatt hours. And then we times that times our price, which is about 8 cents per kilowatt hour, and you get $23.50 to run that one light bulb per year. Now that might not sound like a lot to you, but think about all the bulbs that you have at your place of business. So all those bulbs used 8 hours a day throughout the year add up to about $20, $23. So these numbers add up, and they can be quite significant if you think about it. Again, here's a graphic of what we just talked about. 100-watt light bulb, the hours used, divide the watts. To get watts from 2 kilowatts, you divide it by 1,000, and then you times it by 8 cents. So here's a practice problem for you guys. And the title of this seminar is Energy Efficiency for Business. So let's look at this efficient type of lamp and see how it affects us. So right here we have a 100-watt standard incandescent lamp. It takes 100 watts for us to have that light on. Let's see what happens when we change to a more efficient 20-watt LED lamp right here. So how much does it cost to operate the 20-watt lamp for the year, 2,920 hours throughout the year? So everybody, I'd like you to get out your thinking caps, get out your calculators or smartphones, and we can figure it out. I'll give you a moment, and actually I'll help you with this hint down in the bottom right-hand corner. So 20 watts times the yearly hours divided by 1,000 equals how many kilowatt hours, and then times that times 8 cents. In here, we have a selection of answers for you. So what I'd like you to do is participate. I'd like you to use your arrow tool in the top left-hand corner and select the answer that you think it is. Let's not wait until everybody else selects. Be gutsy, make your calculation, make your call. I see a few people that have selected the $4.67 selection, and that is right. That's how much it costs you to run that bill, that bulb per year. So here's the breakdown. You're looking at a comparison if you use the old technology to the new technology. You're dropping down in wattage, and you're dropping in cost to run that bulb. So instead of $23 per year, you're under $5. So if you do the math and think about all the bulbs that you have at your place of business, this can be a huge energy saver and a huge saver on expense, on paying for electricity. Replacing one 100-watt incandescent bulb saves you roughly $18.82 per year. It's big. Good job on that one. No more math, I promise. Now, there will be some more numbers that we go over because I want to show you some real-world examples, but you can put your calculators away. I won't make you do any more calculations. The takeaway from this is that you now have a skill on how to figure out energy consumption and how much it's costing you. And that is power times time times cost. Okay, let's move on. Here's a graph of energy use at businesses across the United States. So commercial electricity usage, and so we're talking all types of businesses. Branch offices, hair salons, retail stores, office buildings. As you can see here, lighting is significant. Lighting is number one. It's about 27% here. Then you have cooling and heating combined is about 18%. That's the second largest category. And then followed by office equipment, which is much smaller. Some more pretty graphs for you, some pie charts that I know you'll love. Here's an example of an office building energy use with combined energy use. This will be gas and electricity. Now you look at lighting, it's about a quarter of the energy use for an office building. And you have water heating, which is significant, and space heating as well. Let's look at the energy use if we take out the gas component. There we go. So look at lighting. It's much more significant if we're talking about electrical energy use alone. It's almost half. The water component is gone when you just look at electricity, and you have ventilation and space cooling. There's a fan component with that. So that is significant, but not nearly as much as lighting. Other will be assorted stuff that you have in the break room that your employees are using. So what does this slide tell me? It tells me lighting. Lighting is significant for electrical energy use. Another pretty graph for you, pie chart, and this is a different business sector. This is a retail business customers, and this is from real customers, this information. So we're looking at retail usage, and this is combined again. On the left side, we see lighting. Lighting is significant for retail. I think we all know why lighting is significant to retail. Retail customers basically want to attract customers to look at their product, come into their store, and buy things, basically. So lighting is huge. On the other side, if we do the comparison, electric use only, lighting increases even more. It's at 59% if you just look at electric use for retail customers. Huge. You still have your cooling here, fan driven, but it's less significant for this business customer. This is also related to when you have lighting, a lot of lighting with retail customers, the lights generate heat, you have to cool the space, so you're going to have some usage going towards cooling the space and making your customers comfortable. Okay. Our next sector would be a warehouse. Warehouse is a little different of an animal. Lighting is a little bit less definitely less than retail. It's at 32%. You have space heating here, which is significant because warehouse, you have such a large space, a large amount of air, and you have to keep your employees comfortable. Let's look at the energy use if we just break out the electric use only. And you can see that lighting takes a big jump here. It's a bigger chunk of that electric use. Still have a little ventilation and some other stuff that your employees might be using in the break room, but lighting is key again. Lighting is key across all sectors. When we look at lighting, it's significant as far as electric usage and energy efficiency. So lighting opportunities. What are some lighting improvements that we could investigate? We know that less energy consumption equals reduced energy costs. Almost all energy efficiency lighting upgrades result in significantly increased lamp life, which decreases parts and services costs. So we're talking about maintenance. These are other things that are not energy related. They're related to how often you have to change your bulbs out, replace your ballasts, pay someone to actually do the work of changing out the lights, and that can be significant. Also, lighting improves the light quality in your workspace and retail environments. So, what is the most expensive thing for business owners? Paying employees, payroll, having people work. and improving the lighting quality in your workspace improves the performance of your workers. So for office areas, studies have shown that employees are more productive when light levels are appropriate. Most lighting upgrades result in higher quality lighting. By improving the lighting environment at your business, you will improve the productivity of your own workforce. Because there is such a great opportunity for energy savings in lighting retrofits, I'm going to spend some time now discussing their benefits. Let's look at some typical real-life scenarios for commercial lighting. The most common lighting found in commercial buildings is linear fluorescent, and that's what we're looking at right now. Tube lighting, and the older tube lighting is called T12. And the reason it's called T12, it's the actual lamp is measured in 1/8 of an inch. So it's 12/8 of an inch, which is the older, thicker bulb. The newer technology is T8, so that's 8/8 of an inch. So the new technology obviously is better. They also, this technology uses a ballast. The ballast is a piece of equipment that actually translates power into a form that the lamps can use. So all these lights have a ballast in the fixture. It helps operate the lamp. The older T12s use magnetic ballast, and the new T8s use an electronic ballast. The older technology, the T12 magnetic ballasts, are no longer being manufactured, so they phase this out. The government has mandated new energy standards, and basically the older T12s can't meet those standards. So very few companies make these ballasts anymore, or the lamps. They're becoming harder to find and more expensive. So why should you switch? Why should you consider T8s? Why go to a new system? Well, you could maintain the old system, T12, if you were really in love with it. It'd be harder for you to find the bulbs. It's going to be more expensive. And the T8s are better. They're better in performance, better energy efficiency. They last longer. They give off better light. And they give off better color rendition, or CRI. CRI is a term that is used in the lighting industry to detect how accurate an artificial light source is. So how accurately it displays colors in a space. And that can be important if you're, I always use the analogy, you can tell that if you're getting ready for the day, and you're getting dressed, and I'm sure we've all done this, you have one black sock and one blue sock, and it's because of the light source you can't tell the difference. Well, eventually when you get to work you can tell that, and you're pretty embarrassed. This is a way that you eliminate that. With the T8s and higher CRI, you can tell the black socks from the blue socks.
Chris, can I ask a question about the T8 and T12s?
Sure.
Can people just replace the T12 lamps with the T8 lamps without changing out the ballast, or how does that work?
That's a great question, Beth. If the ballast is not a T8 ballast, it will not work. T12 lamps use magnetic ballast. T8s are more efficient, and they use an electronic ballast, which runs at a higher frequency than magnetic ballast. So you need an electrician to change out the ballast if you're going to switch from a T12 to a T8. Okay, linear fluorescent. Here's a real-life example of an office. The existing setup was 24, 130 watt, 3 lamp T12 fixtures, which was overlit. And basically the older T12 fixtures are manufactured and installed to be at a more brighter because they lose brightness over time. They use light output over time. So they overcompensated when they first put these back in. I put these lights in, 10, 15 years ago. And that was to adjust for the depreciation in light output. So we changed, the change was to go from the old T12 to the new T8 fixtures. And it's a 1-for-1 fixture, but by changing the T8s, they're more efficient and they provide more light. So instead of using 3 lamps, we can use 2 lamps per fixture. So again, it was 24 fixtures, but we went from 130 watt 3 lamp T12 to a 55 watt 2 lamp T8. Now the hours of operation were significant, 10 hours a day, 5 days a week, and then somebody came in on Saturdays to do extra work, so 4 hours a day on Saturdays. So the annual energy savings with this project was 4,941 kilowatt hours. The annual dollar savings, this is a small business customer, scheduled 32, was $413. Now, this change will pay for itself in energy savings alone. But there's also incentives from the Energy Trust of Oregon to help offset the cost of this project. Now, the Energy Trust of Oregon is a nonprofit agency that is set up to help customers in Oregon save energy. Residential customers, business customers, they all pay into a public purpose charge, which goes to funding directly Energy Trust incentives. And this is a way that paying customers recoup that investment. If you do energy efficient projects with the Energy Trust, a lot of times they're incentivized and you can get money back towards a project. So with this project, the Energy Trust incentive was $720, which is pretty good. So what might have been a 4.5 or 4 year payback switched to 2.3 years, and that's on energy savings alone, not factoring in anything like maintenance or the benefit to employees. So the return on that, the simple payback after incentives, 2.3 years, and then a return on investment of 43%, which is excellent for an investment. These types of lighting projects make financial sense. So our next example is, say you have a building that is not as old. Maybe the lighting is 6 to 10 years old. It'll be T8, but it's original T8. And we call that first generation T8 system. It's pretty common with the lighting that's around 10 years, 6 to 10 years old. Now, is it worth it to change these out to the new T8 system? I would say yes. The new T8s are high performance, and they last anywhere from 24,000 to 50,000 hours. Versus the older T8s, you might get 20,000 hours out of those. So you can realize 25% or more of energy savings. Sometimes it's a little bit lower. It just depends on hours of operation. It could be somewhere in around 10 to 15%. A lot of times with the older T8s, you'll have that problem of it being overlit. Too many lamps, you can de-lamp. There's a lot of things that you can do to save energy and make this project work for you. So long hours of operation definitely will help. This can definitely work in a retail location or medical offices that might be open 24/7. Long hours, and the first generation T8s moving to the new generation T8 makes sense. Okay, so our next example is warehouse lighting. I work with a lot of customers that have warehouse lighting, warehouse spaces. Sometimes they use it for stores, sometimes it's mixed use, could be retail or manufacturing. And in warehouse space, we see these types of lights we see them a lot. So on the left-hand side, we see a metal halide fixture. And on the right, we see a high-pressure sodium. The metal halide is problematic because it basically fades over time and changes colors. It starts out being pink, then it goes to yellow, and then finally blue before it dies. Now, the high-pressure sodium are efficient, but they get really bad color. And, they're good for maybe an outdoor security light, but bad for indoors. Definitely cannot tell your blue socks from your black socks if you're using this kind of light in a warehouse. So what we recommend doing is changing those to high-performance T8s, T8 fluorescents. These lights are very bright. They're meant for long hours. They're meant to stay on. And then the new T8s the high-performance T8s do a great job of being more efficient and give you better light quality as a replacement. The new T8 replacement works with occupancy sensors. And these older high bay fixtures do not work with occupancy sensors. So in a warehouse, that can be very important. You can reduce your operating time and provide significant additional savings. So here's our example of a high bay project, real life. So the existing lighting this customer had was 20 460 watt metal halide high bay fixtures, and the change was to 222 watt fluorescent high bay fixtures, and those will be T8s with occupancy sensors. Basically, there'll be 4 tubes of high output T8. So the hours of operation, 10 hours a day, 6 days a week. And take a look at the energy savings here. That's pretty significant. 17,966 kilowatt hours. And your annual dollar savings is $1,500. So if you think about that, that's $1,500 that you're not spending on an annual basis because you've made the change going forward. That's without incentives. And your simple payback without incentives is 3.5 years. Now we throw in the energy trust incentive, $2,400, and that drops the simple payback to 2.1 years. And again, another attractive return on investment at 48%. You know, if you're leasing the warehouse space and you're on a 5-year lease, this project makes sense. If you own the warehouse space or the building, it's a no-brainer. You should do it. So again, lighting, huge savings. You know, just again, over and over, lighting is really pays back for itself in energy savings. So our next example is lighting technology called LED. And LED stands for light emitting diode. It's the latest and greatest in lighting technology. With LEDs, we get much longer lamp life. Typical life for a standard incandescent bulb that looks like this is well, they say on the box it says about 2,000 to 8,000 hours. Customers say that the bulbs last them about a year, but I talk to tons of customers that say that they have to change these out at least twice a year, which is a big pain. You know, again, think about the maintenance factor of changing bulbs out 2 or 3 times a year and how much it's costing you to pay someone to twist bulbs, basically. So the payback only includes energy savings. Only on energy savings, this project makes sense on maintenance savings alone. So you have that, if you change the LED, you're going to increase that lamp life. And with LEDs, they've come a long way. They're improving the efficiency of them. They're dimmable. They've improved the beam spread. When they first came out, they were only spot, and now they've improved the beam spread of LEDs to also incorporate some aspects of being a flood lamp. And then they've also improved the color rendering and also the color warmth of the bulb. And now they have a lot of bulbs that are very warm, around 2,000 Kelvin, and we see a lot of restaurants putting those in hospitality for that warm look and feel. You know, basically they start out from a warm white to a cool blue. You can get anywhere in that range. And right now, when you switch to these, we see a real quick payback when you incorporate the incentives. The majority of the projects that I do with my customers in retail, if they're changing screw-in, halogen or incandescent to LED, it's just about 1.5 years. But it can be anywhere from 1 to 3 years depending on hours of operation. But with the incentives right now, they're so good that this is kind of a slam dunk project, if you like to think of that in those terms.
Chris, can I ask a quick question?
Sure, Beth.
You may have already covered this, but I wasn't entirely sure. What is the typical return on investment to upgrade from incandescent to LEDs?
Well, again, that's a great question, Beth, and I'd like to say it depends on a number of factors. It includes the type of LED or the type of incandescent that you're replacing and the wattage that's being used, the cost of that replacement bulb, the lifespan of the existing bulb and the new bulb, and the hours of operation. So the ROI can fluctuate, but generally we see something around 40% for this type of investments. And the simple payback screw-in LED lamps often pay for themselves, like I said, in about 1.5 years, less than 2 years for sure. So here's your real life example. This was a restaurant that had 40 of the smaller MR16 bulbs, 35-watt bulbs, halogen, and they were replaced with 40 LED MR16s. Now look at the difference between the amount of energy that they use. You're going from a 35-watt halogen dropping down to a 5-watt LED. It's 1/7 of the energy. Hours of operation, 12 hours a day, 7 days a week. These long hours help make that simple payback more attractive. So annual energy savings, 5,124 kilowatt hours. And this the example of small business customer again, and your annual energy savings is $428. That's $428 that's not costing you if you decide to move forward with the project year after year. Throw in the Energy Trust incentive, which is $600, and you're looking at a very attractive simple payback of 1.4 years and an outstanding ROI of 71%. Talk to your boss, your CEO, the accountant about that return on investment. You might get a promotion. You might even get moved to the corner office. It's going to look that good to the people that you work with. The X factors are your cooling savings and maintenance savings to think about. Exit signs, these are generally incandescent or fluorescent, and you can save, they're on for long hours of operation, they're always on. So you can really save some energy with these. Not a major part of your business, but it's another area where you can save energy. The incandescent bulb usually lasts about 2,000 hours and runs at 40 watts. If you go down to a fluorescent, it will last you longer, 10,000 hours and 18 watts. But if you go to an LED, you're looking at 50,000 hours of operation, which equates to 6 years, and they only use 6 watts. Really good idea for a project there. Occupancy sensors, so we talked about before with warehouses, they can help the human aspect of leaving the light on. I know that because I have small kids and I'm constantly telling them to turn off the lights in the house. Same thing here. These occupancy sensors can be wall mounted, which is the switch plate, or you can have it ceiling mounted, which would be more for like a gym or cafeteria, or fixture mounted. That's what you're going to see in a warehouse application. Great way to save energy and make your project look that much better. So, it's participation time again. I'd like you guys to use your marker and select which opportunity you think is most likely for you. Which one looks like you might have a chance to do that? Is it going from T12s to T8s, or old T8s to new T8s? Do you have high bay lighting in your warehouse that you're looking to replace? Incandescent or halogens through with LEDs? Your exit signs or occupancy sensors? These are all projects that you can do and take advantage of Energy Trust incentives. So we're going to move on to our next section, which is heating and cooling. But if you have questions about lighting, please send them to Beth and we'll get them answered. Okay, HVAC, which is heating and cooling. HVAC systems, this is what we have a picture here is a rooftop system. And this is a package system. It means heating and cooling. The heating and cooling equipment is in the same box. It's often up on your roof, usually 5 tons or more. And these units can easily heat and cool 5,000 to 10,000 square feet or more. These systems are pretty effective. they can last up to 50 years. Typically, the cooling and heating units lose their efficiency after about 15 or 20 years. So that's what we're recommending. We're not recommending go out and replace this right away. It's just have a knowledge of how old your system is. And if it's at that 15 to 20 year mark, just know that it's losing efficiency at that point. You might want to consider newer technology, more efficient technology. Other than that, just keep it running well. You don't need to change anything, but we do recommend that you change the filters. Have it serviced by an HVAC technician at least once a year. When you're thinking about investing, it's better to go with a high efficiency unit than a low efficiency unit. That first time cost is nowhere near the life cycle costs you would receive if you get a unit that's not energy efficient. Here we have a split heat system. Split system, it can be a heat pump or an air conditioner, typically outside. The furnace most likely is inside. And then that could be an AC unit or ground mounted or a heat pump. The heat pump can show up outside or on the wall. Basically, the cooling and heating are separate in this unit, and they're separate from the air handler. So the heat pump uses a refrigeration coil that goes to the air handler inside your house. So heat pump does heating and cooling. Same rules apply here, is that no need to rush out and replace this thing, but have that rule of thumb, the 15 to 20 year mark, where you want to think about the efficiency of the unit. You definitely want to get it serviced annually, keep the coils clean, and then think about, you know, if you have an outside air conditioning unit, the heat pump is a good replacement for that outside air conditioning unit because it does the heating and cooling more efficiently. So just something to consider, the life of the unit, and you get what you pay for. Buying a more efficient unit when you have to replace it is definitely worth that first cost. Combustion services, furnaces, don't see a lot of these out in the field, but definitely don't see 4, usually 1 or 2. They're efficient too. They last a long time. Same rule of thumb, the 15 to 20 year mark. The older models are about 89 to 92% efficient, where a new system, if you're considering it, would be about 95% energy efficient. So it's definitely worth paying for that energy, extra energy efficiency moving forward with the system. Combustion unit heaters, we see a lot of these in warehouses, but you also see them in retail and some restaurants, just depending on the type of building and what was there. Sometimes people keep them there. They are not super expensive, but they typically work on gas. We see a lot of these around. Hopefully it has a programmable thermostat for the unit heaters. A lot of times they just have a switch. But what we would recommend here is consider replacing with a radiant heater, which looks like this. And that can be, you can save some energy, even up to 60% on the unit going to a radiant heater. A radiant heater would be this strip will be up on the ceiling or on the wall somewhere, and this basically does a better job of heating objects and people rather than the whole room. This unit gas heater just heats the air in the room, so it's not as efficient as the radiant heater. It's a good way to be more efficient in heating a large space such as a warehouse. Packaged terminal air conditioners, PTAC units, or packaged terminal heat pump units, which are PTAC or PTHP. And you see a lot of these in hotels, dorm rooms, condos, multifamily. And there's a good opportunity to improve the efficiency of these units. If you have a PTAC unit and change that to a PTHP, a packaged thermal heat pump unit, because the heating element in the heat pump is much more efficient, and you can do with both of these. If you go from a PTAC to a PTHP, you can improve the cooling savings up to 25% and the heating savings up to 50%. There's also a current bonus from the Energy Trust of Oregon regarding these units. The bonus for heat pumps for multifamily and assisted living, and it's a 25% discount, including hotel and motel customers. Here we have Zonal Electric Heat. What we have here is a mini split ductless heat pump. Can be a good replacement for zonal heaters. So what I'm talking about, zonal heaters, I'm talking about baseboard heaters that are on the floor, or cadet small square heaters that are in the wall. Those are resistance heating. They're not super efficient. You can really improve the efficiency by going to one of these mini split ductless heat pumps. Each unit can be in one room. It handles one zone, and it moves heat from outdoors to indoors and to provide heat, and then moves heat from indoors to outdoors to provide cooling. And these are the heads that are in your room. You probably have seen these before, and they are efficient because they run on remotes, and they only heat or cool when there's a human in the room using the remote to cool or heat themselves. So they're not running all the time like the baseboard or cadet heaters. I definitely would, if you have baseboard or cadet heaters in your multifamily or your business property, I would definitely have an HVAC contractor come out and give you a bid for replacing those with the mini split ductless heat pumps. It's definitely worth your while to take a look at the numbers. Okay, now we're moving on to low cost and no cost lighting opportunities. And these are things that you can do right now without an investment. Outdoor, if you have multifamily or you have an office and you have a parking lot and you ever notice that your lights are on during the day, it's sunny outside and your lights are still on, well, that means your photocell on the light is actually dirty, and it actually thinks it's darker outside than it really is. So you want to make sure that you clean those photocells if you see that happening. It's a way that you can save energy. Open your blinds during the day. You can open your blinds to windows that have sun coming through them. That way you can use natural energy to light your space rather than turning on a light. That's a good way to save energy. CFLs are still a good way to save energy. I know there was a lot of problems when they first came out, but the new versions are really good. I have some of them in my house. So if you don't like the look of them, they make them in actual bulb shapes now, or you can work them, you can use them with lampshades or where they're not seen. Then also the old one, just going back to my kids, turn off the lights in unoccupied rooms. Tell your employees. Put a sign up next to the light switch. Any way you can get your employees to turn off the lights. Low cost, no cost heating and cooling. Programmable thermostats, huge. That way what you can do with these is basically set it and forget it. It'll run the system for the hours that you're there and have a setback point for when you're not there. The older thermostats can get uncalibrated, so if you have an old thermostat, it's probably not that accurate. You can replace it with a programmable thermostat. It costs about $50 to $80 at a big box store. Make sure you know how to wire it before you set it up. And then you can set your optimized thermostat set points. We recommend 70, if you're there in the building, heating to 70 degrees, cooling to 74 degrees. And then if it's unoccupied, set it back so you're not wasting energy if no one's there, and go down to 60 for heating and 80 for cooling. Schedule your employees to work at the same time so you don't have long hours and you're not having people come in on Saturday and Sundays and use energy when it's not necessary. So if you can do that, that's a good way to do that. You can even do that with the people that clean up your building after you're gone. Regular maintenance on your HVAC equipment, that's huge. Annually, if it's older, semi-annually, it's important to have that system running as efficiently as you can. Water heater, most water heaters are set to 140 degrees factory setting. You can turn that down. Gas has one thermostat at the bottom. Electric water heaters have two, one at the top and one at the bottom. Plug loads, low cost, no cost, no cost. What my challenge for you is to take inventory of what you have at your place of business and what's using energy. So do an audit. An easy way to do that is with a device called a kilowatt, which is available from the Energy Trusts of Oregon and local libraries. You can rent this device, and you plug things into it, and it'll tell you how much energy it's using over a period of time. Great way to do an audit at your business. So you basically want to plug in all the things that your employees are using, fans, heaters, anything that they have that they're using at their desks. You're paying extra for them to use those things. It's a good idea to understand how much energy they're using. You have to do it while they're there, and then I know it's a pain, but you have to actually do it at night. To get kind of the baseline to understand what's being used when the building is occupied and what's being used when there's no one there. Once you get a handle on that, then you can have that frank discussion with your employee that has their leg warmer turned up all the way to the highest setting because they're cold, and you can tell them actually how much energy that's using and have that discussion. Okay, I talked about the Energy Trust of Oregon before, and it's an independent nonprofit organization dedicated to helping people in the state of Oregon save energy. It was created by Senate Bill 1149, and it's funded through your public purpose charge. Now, if you want to know what that looks like, it's 3% of your bill. On your home, on your business, it's 3% of your bill. It's listed on your bill under the public purpose charge. And PGE, Portland General Electric, has partnered with the Energy Trust. We're a resource for you, for all of our commercial customers. We can help you identify opportunities to save energy, and then we get you connected with the proper Energy Trust program. So here are the incentives that that are available for our commercial customers. Lighting is huge, heating and cooling upgrades, grocery equipment, your refrigerator replacement and recycling. They'll come out and haul it away and give you $45 for it. PC power management, insulation. They actually have just doubled the insulation bonus incentive for customers that have zero insulation, so that's a real good deal from the Energy Trust right now. And there's also lodging and food service equipment. There's a commercial kitchen bonus that's available right now, which is a tiered system. And there's also custom projects. If something doesn't fit in the parameters, if it's not prescriptive, if you have a funky light system or heating and cooling system, the Trust is always willing to work with you to try to make that project work. So here's my challenge. My challenge to you is to take action. Become more energy efficient. Use your pointer now and select what you're going to do moving forward at your place of business or with your employees. Are you going to track energy consumption, set goals, review and implement low-cost or no-cost suggestions, ask us about your potential projects and incentives? I'd love if you did that. We're ready to answer your questions. Or engage your employees and assign tasks. give your employees the ownership of energy efficiency. So here's my contact info. I'd love it if you gave me a call, sent me an email, talk to Beth. That's my number, that's my email address. Write it down. Give me a shout. I'd love to talk to you about saving energy at your business. And that way we can find out what the next best steps in energy efficiency are for you. I'd like to thank you for attending this webinar today. I will now connect you back to Beth for some additional information and to our question and answer session.
Thanks, Chris. Before we proceed to the question and answer portion of the webinar, I'd like to remind you that you can still submit questions to me through chat, the host, and I'll ask them of Chris. And you can also just let me know if you'd like to ask the question out loud, and I can do that as well. And now, Chris, the first question we have is, does insulation really help to save energy? What insulation levels are efficient?
That's a great question, Beth. Insulation levels definitely help save energy. They also help with the comfort levels that you have in your place of business. So it's the intangibles. So what we recommend are R11, which is the thickness of insulation in walls, and R19 in ceilings and attics. And proper insulation is an essential part of the energy efficiency formula. It lowers costs, and it has that intangible factor of making your employees comfortable year-round. There are incentives to improve the insulation in your business from the Energy Trust, specifically if you have zero insulation right now.
Thanks, Chris. And the next question is, T12s and T8s aren't always easy to identify. I've heard that there are little devices that you can point at a light to be able to tell what type of lamp it is. And here, maybe they're talking about the ballast as well. What are those called, and where can we get one?
It's another great question, Beth. Those devices, they're called lighting discriminators, and it looks like a fancy garage door opener. It basically will detect if it's electronic or magnetic ballast. I believe that they're available through Plaid Electric. I think they cost maybe about $15 or $20. We have cards, lighting cards, here at PGE. If you contact us, we can measure. We can send one out to you. They're free, and it's just a cutout that is cut into the shape of a T12 bulb or a T8 bulb, and you just if the bulb is exposed, you can use this card, and you can just see exactly if you have T12s or T8s. Contact Beth or myself, and we can mail you one of those cards. No problem. It's free.
Thanks, Chris. And that was the last question, and I'd like to thank you all for joining us today.